These are some application problems for distance and midpoint as well as for lines. To get from point A to point B, you must avoid walking through a pond. To avoid the pond, you must walk 34 meters south and 41 meters east. So I'm just going to start by drawing our pond here. Anytime I have a story problem, I always start with a drawing of some sort. So here's my pond. All right. Terrible, but it's okay. All right, so you are going to avoid walking through the pond. So you're kind of over here, right? And you need to get to over here. So you're going to walk 34 meters south and then 41 meters east. And then to the nearest whole number, how many meters would be saved? That's important. It's not asking us a direct question. It's kind of going to ask us a couple steps. How many meters would be saved if it were possible to walk through the pond? So first of all, I have to think about how far it is to walk around the pond. Well, that's pretty simple. I just walk myself this way, 34 meters, and then 41 meters. And I add those together, 34 plus 41. That gets me 75 meters if I have to walk around. So what the question is asking is how many meters would be saved if it were possible to walk through the pond? So now I have to think about if I was going to walk through the pond. So if I was going to walk through the pond, it'd be something like that. There's your 90 degrees because it says south and east. So I know it's a right angle right there. So then I can set it up as, if I have to walk through the pond, that would be finding the distance. Think about which is going to be easier. Should I do the distance formula or should I do Pythagorean theorem here? Because I don't have any points like x, y, the best thing to do is going to be to use the Pythagorean theorem. So 34 squared plus 41 squared equals c squared. You're going to be dealing with some big numbers, so grab your calculator and see if you can solve for c. See if you can figure out what c is. I'll give you some time. You should have come to an answer of 53.3. So notice it is shorter to walk through. Obviously, the shortest path is always the straight line. So now the question is how many meters would be saved if it were possible? So saved means the comparison between the two. So it would have taken 73. You could have done it in 53.3 if you could walk through water. So you're just going to compare the two, 75 minus 53.3. I'm going to do that one in my calculator. Type that in, and it gets me 21.7 meters I could have saved. So notice the only real part that we were working on in class is this through the Pythagorean theorem. Everything else was just adding, subtracting, and kind of using that logical sense, logical thinking to figure out what the question was asking. All right, for the next one. Marine biologists off the coast of the Bahamas want to measure the length of sharks. So length automatically makes me think of distance. They create a grid of PVC pipe, that's that cheap white pipe that you use for different plumbing and things, and lay it on the ocean floor, about 20 feet below them. Each grid square measures 2 feet by 2 feet. Shown is a diagram of one of the sharks swimming above the grid. Find the approximate length of the shark. So I actually did see this actually happen on Shark Week. So this is kind of what they do if they don't have all that fancy equipment to measure the sharks. So each one of these is 2 feet long. Each one of these this way is 2 feet long. So we'll just keep that in mind. So I've got this shark, and you can kind of approximate, but to me the tail looks like it's closest to that point there. I'm going to kind of draw it up, and it looks like it's a little bit short of that, but that'd be a good approximation of the size of the shark. So then what I'm going to need to do, come down here and here, and then I've created a triangle. And with a triangle, I can use Pythagorean theorem. Now be careful as you count these blocks. Remember, each one of them is 2. So each time you count it as 2. I'll give you a second to count the sides of the block and try to set up the Pythagorean theorem. So I'm getting this side to be 10, 2, 4, 6, 8, 10, and this bottom side to be 8. Again, I'm counting by 2s. 10 squared plus 8 squared equals c squared. 164. Add those together, 164. And at the end, we always square root it. And it doesn't talk to us about any sort of decimals, how they want it rounded to. So we're just going to round it to whatever you feel is best. On my calculator, I think the best answer is going to be if I put 12.8 feet. Make sure with any of these problems that it's always a reasonable answer. If you had just stuck with 164, that is a very long shark. There's no way a shark is that big. So then you can always kind of think, okay, well, maybe my shark is not 164 feet and I need to do something. I forgot to square root it, right? So always kind of think logically about the answer at the end of your problem. When it says show work to justify, just make sure you show some sort of math. That Pythagorean theorem problem work right there is perfect. Okay, for the next one. While planning the layout of her yard, Laura created a grid system representing her backyard. Laura has a swing set in the middle of her yard. That's this right here. At the point 914. The yard also has a large maple tree on the right side. That's this right here. At the point 1720. Laura wants to build a fire pit. So a little fire pit over here. And she wants to build it on the left-hand side, but wants to make sure everything is symmetrical, meaning she wants to make sure the distance, right, between the maple tree and the swing set is the same as the swing set to the fire pit. At what coordinates should the fire pit be built? So I'm going to kind of bring this off to the side here. Let's see. There's 2 ways we can do this, and I want to make sure I show you both. This is actually a midpoint formula because this is the middle. Right? And we've got one of the ends, and we want to try to find the other end. So one method is we could use our flowchart method. Our flowchart method looks like this. You would put the 1720 at the top or at the bottom. Most important thing is that you put the 914 in the middle because it's your M. And then your other point that you're trying to find can be on the other side. The midpoint, the middle swing set has to be in the middle. If you remember how to do it that way, go ahead. If you're an equation type of person, I'll help you set up the first equation. Remember, the middle point has to be the M equals because it's M equals and then that big old parenthesis of stuff, right? So M equals, so we're going to use the 9. 9 equals. Then I'm just focusing on my x's, 17 plus x over 2. And I would solve that for the x. So whether you're doing the flowchart method or the equation method, Choose one of those and see if you can finish this problem on your own. Right, so if you did it the equation way, you would multiply both your equations by 2 on both sides, and then you would just subtract out whatever number was left next to your letter. So I got 1 for x, and I got 8 for y. So my final answer makes 1, 8. If you use the flowchart method instead, you would say, how do I get from 17 to 9? I would actually subtract 8. And so I would do that same exact thing again. I would subtract 8 again. If the difference from 17 to 9 is negative 8, the difference from 9 to my next number would be 1. All right, and the same thing for the 20. 20, how do I get down to 14? I subtract 6. Then I subtract 6 again. I want that to be the same distance. That's how this 9, 14 ends up in the middle. Subtract 6 again, and I get to the 8. So whichever method you prefer is completely fine. Notice you get to the same answer either way. So this little fire over here is at the point 1, 8. Okay, for the next side, this is all about lines. So this is going to be a little bit simpler. You're getting ready to move into your own apartment. You've lived in your parents' house for 18 years, so you have a lot of stuff to move. You decide to rent a truck to help move your things. The truck rental company charges a rental fee of $29 plus 20 cents per mile. $29, that's a one-time fee, and then 20 cents per mile. You probably recognize the word per as something you're going to have to multiply. Create a linear equation for the cost, C, that means they want the cost to represent the letter C, for X amount of miles. So C equals, what does it cost in order to rent this truck? See if you can write something down. You've already got your C equals at the beginning, so all you have to do is think about how much it is per mile, your total rental fee, and then just putting in a variable where it belongs. You should get 0.20 for the 20 cents per mile, that's your X, plus the $29. And that's it for that equation. Now part B asks us to use that equation. How much would the truck cost if you were traveling a total of 123 miles? That's our X. X was miles. So we're going to do the same thing, except we're just going to plug in the 123. Grab your calculator, multiply and add the 29 in, and see what you get as your answer. When I multiplied, I got 24.6, add the 29 to that, and I got myself an answer of $53.60 to rent this truck. All right, for the next one. Cherry on Top is a local ice cream shop. They sell a single scoop of ice cream for $2 each and double scoops for $3 each. Last Saturday, they made $36 in the afternoon. Write a formula to express this situation. Use X for single scoop and Y for double scoop. So I need to have both my variables in the same equation. As well, I have to have my total in there of my 36. Your equation's not going to quite look like it did up here on part A. It's going to look more of like a traditional equation like AX plus BY equals C. So 2X to represent my single scoops, $2 for a single scoop, plus $3 for a double scoop. And then my total would be 36. Part B, if they sold 9 single scoops, how many double scoops did they sell? So we're going to plug 9 in for the X, and then go ahead and solve. I'll let you try that part. You should get to a total answer of 6 double scoops. Okay. For our last problem, have a little table graph here. A physical therapist randomly selected 10 patients to complete 2 physical therapy fitness tests, right? Maybe one was doing jumping jacks, another one was running on the treadmill. Okay. The patient scores on each test are shown in the scatter plot. So let's just look at this dot right here to make sure you guys understand what's happening. So this patient scored a 70 on the first fitness test, and then it looks like they scored right between a 60 and 80, so another 70 on the second test. This person up here scored a 90 and then 100, right? That's what's happening on this graph. All right, let me come in and erase that, not to confuse us for what we're about to do. So part A says, is the association between the 2 fitness tests positive or negative? Well, there's a couple ways to think about it. Look just at your dots. Which direction are they going? Are they going positive or negative? Uphill or downhill? Yeah, they're going uphill. So this association is going to be positive. Another way to look at it, and I'll just write that out, points are going uphill. Another way to think about it, look at one of these points down here. This one right here. They got a 50 on one and then a 50 on the other. But we were just talking about this one. That was a 70 on one and a 70 on the other. So as one test goes up, the other one goes up as well. And then this one, 90 and 100. So the higher one is, usually the higher the other is. All right, now we get to predict. Predict is just a guess based on the information that we have. Predict the fitness test 2 score for a patient who got 100 on the fitness test 1. Here's my 100 on my fitness test 1, and I'm trying to approximate where on my graph a point best fits. So you have all this space here up along this line at 0 to put up along the line at 100, to put your dot. So this down here doesn't work. That does not fit in the line of where the rest of the dots are. Okay. So think about trying to place your dot where it fits best. You could definitely have some different answers and then both be correct. Many answers could be correct. So place your dot where you think it best fits along the other dots, and then we'll talk about it. I'm going to place my dot right here, but anywhere above here, there would work, even down here might work. Anywhere in that region should be good. It kind of follows along that general path of the rest of the points. So I'm going to go ahead and say 80, but anywhere from a range of like 70 to 110 would be a correct answer. Right, great job on that. Thanks for trying those application problems. If you have any questions, you just let me know.